Good evening, children.
Good evening, ma'am.
Yeah, hi, good
Good
evening.
evening, ma'am.
Good evening, children. Good evening. All right. So last class we took the introduction to this chapter, a pair of linear equations and two variables x and y. And we also understood how to solve a pair of equations using the elimination method and the substitution method. Using the elimination method and the substitution method. We learned how to solve equations using the elimination method and the substitution method. You don't have cross multiplication method this year. All right, so let's continue. So see here, children, solve for x, y, and z. Solve for x, y, and z. You have three equations in three variables x, y, and z. See here, you have three equations. This is equation 1, x, y, z. This is equation 2, x and z. This is equation 3, x and y. So I've numbered the equations. I've written the equations one below the other. I've called them 1, 2, and 3. Okay, so you can actually, such equations can be solved in more than one method. I'm explaining what I have worked here. I'm explaining what I have worked here. So here what I've done is, I've taken up, I'll tell you the idea behind this working, okay? I've taken equation 1 and 3. See, using this idea, you can get a different idea also. I have taken equation 1 and 3. Okay. Now, in equation 2, there are two variables x and z. In equation 2, there are two variables x and z. So what here in this working, the idea is take equation 1 and 3. Okay, take equation 1 and 3. And if you eliminate y there, you will get a new equation in x and z. Equation 2 has variables x and z. Take equations 1 and 3. Eliminate the variable y. So when you take equations 1 and 3 and eliminate the variable y, you will get a new equation in x and z. You will get a new equation in x and z. Now solve the second equation and fourth equation, which are in x and z, and find the values of x and z, and hence find the value of y. That's the idea used here. That is the idea used here. So see here, I've taken the first equation and the third equation. And the idea is to eliminate y. So multiply this equation by 3, the next equation by 2. And you can see I've written the equations here. So when you multiply by 3, 3x, 6y, 3z, and 7 3s are 21. Here this will become 4x, 6y, and 2. Okay, so I've written the two equations. Here I've solved them. What will happen? Plus 6y minus 6y gets cancelled. Plus 6y minus 6y gets cancelled. 3x plus 4x, 7x. 3z plus 3z. Plus 6y minus 6y gets cancelled. 3x plus 4x is 7x. Plus 3z is equal to 23. This is a new. Now you will tell me. Now when we solve this, we have not found any value. No, we solve these two equations not to find not to find the value of any variable x or z. We just want a new equation in x and z. So now we have equation 4 in x and z. Now take up 2 and 4 and solve it. This you know how to do. Solve 2 and 4. So when you solve 2 and 4, you get x, then you can substitute and get y and z. Work this, children. Please write down the question and work this. So what you can also do is, I'll tell you so that you will also know how to think. So what you can also do is you can take up the first and second equation, correct? You can take up the first and second equation. Now look at the third equation. What does the third equation have? X and y. The third equation has x and y, variables x and y. So when you take the first two equations, you must eliminate the variable z. You must do something to eliminate the variable z so that you get a new equation on x and y. Is the idea understood, children?
Yes, ma'am.
Now, suppose if you want to solve 1 and 2, look at the third equation. What are the variables in the third equation? X and y. So when you take 1 and 2, equations 1 and 2, you eliminate the variable z. You get rid of z. So when you get rid of z, you will get one new equation in x and y. That equation and this third equation, you can solve and find the values of x and y. There are many ways, children, you can explore. Once you get a few basic ideas, then you can explore. You can do it by the substitution method. Now I'll give you time to work. I'll not disturb you. Please work. Done, children? Finished writing?
No, ma'am.
Okay.
Complete, ma'am.
Yeah.
Completed, ma'am.
All right. Okay. See, so like this, you can think in different ways. Now, the same question we are discussing. So the third equation you see has two variables x and y. So what you can also do is you can take up the first equation. Look at the first equation, it has x, y, and z. The second equation has x and z. So what you can do is take up the first equation, take up this equation, write z as 7 minus 1 minute. I'll tell you why I'm doing that in a second. Take up the first equation, children. In the first equation, write z in terms of x and y. So you will get z is equal to 7 minus x minus 2y. Okay, z is equal. Take up the first equation. Write z in terms of x and y. So z is equal to 7 minus x minus 2y. Now what you do? Now take up the second equation. Take up the second equation, and in place of z, use this one. X plus 3 into, in place of z, use this 7 minus x minus 2y. See, what is the idea here? Now the third equation has x and y. So you want another equation with x and y. You want another equation with x and y. So what you're doing, you're taking up the first equation. So you don't want z, right? You don't want z basically. So you're taking the first equation and writing z as 7 minus x minus 2y and substitute that in the second equation. In place of that, when you use this, you will get a new equation in x and y. So it will be x plus 21 minus 3x minus 6y is equal to 11. And then you know what to do. 3x, so it will be minus 2x minus 6y is equal to minus 10, I think. And then minus x, whatever, minus 3y is equal to minus 5. So you can use a substitution method like this. Taking up the first equation, writing z as 7 minus x minus 2y and substituting this result in the second equation in place of z. In place of z, we are writing 7 minus x minus 2y. So we get a new equation in x and y. Now you can solve this with the third one. From the first, we substituted in the second. So we get a new equation. That new equation is the third equation you can solve. Yeah. Try this, children. It's similar. Just try it. You have three equations. All the three equations have x, y, and z. I'll just come back. Please try this. I'll just come back, children. Yes, children, I'm back. Share your solution. What are the values of x, y, and z?
Ma'am, I got x is equal to 2, y is equal to -1, and z is equal to 1, ma'am.
Okay.
But I got x is equal to 1, y is equal to -3, and z is equal to 2.
2, huh?
Yes, ma'am.
No, but you can just check, Sashank. See here. We have one equation which says x plus y plus z is 2, right? Now, if you use these values 1 minus 3 plus 2, you get 0. So you're wrong somewhere. But this one works. You can check your solution, actually. You can substitute the values in the equations and check if your values are right. So 1 minus 3, 2 looks incorrect. Anybody else? Yeah, so
Ma'am.
Madhumita, yeah, tell me.
Ma'am, but y is -3, ma'am. No, ma'am.
Is it Sashank?
No, ma'am, I found.
Sorry?
No, ma'am, sorry.
Ma'am, I'm getting x equal to 2, z equal to 1, and y equal to -1.
Yeah, that looks right. Yes. Correct. Yes. So see here. So you can see x, y, and I'm sorry, the three equations 1, 2, and 3 here. So I've taken the third equation. I've taken the third equation. I've written y in terms of z and x. Okay. I've written y in terms of z and x. I've called that equation 4. I've called that 4. Now I'm substituting this 4 in 1 and 2. I'll tell you, you can do it in different ways. This is the idea I've done. I've used here. So I've taken one of the three equations. Okay, all the three equations have x, y, and z. All the three equations have x, y, and z. So I've just taken one of the three equations. So I have taken up the third equation and I have written y in terms of z and x. Okay, so this is 4. Now we used 3 to get 4, right? So leave 3. Substitute this one in 1 and 2. Substitute this in 1 and 2 and you will get new equations 5 and 6. Solve those equations and find the values of x and z and hence find y. This idea you can, 1 minute, I'll tell you once again. Okay, I'll tell you once again. Oh, we have 3 equations here. All the 3 equations have the 3 variables x, y, and z. That's the first thing. You can take any one of the 3 equations. You can take any one of the 3 equations. I have taken the third equation. And you can write any one variable in terms of the others. You can write x in terms of y and z. You can write y in terms of x and z. You can write z in terms of y and x. I have taken, so what are the things you should remember? You can take up any one of the 3 equations. I have taken the third one. You can write any one variable in terms of the others. I have written y in terms of z and x. So I have taken the third equation and I have written y in terms of z and x. So now I'm calling this 4. Now from where, how did I get 4? Using 3, I got 4. So leave the third one. Substitute this 4 in 1 and 2. That means in 1 and 2, in place of y, use this one. 3z minus 2x. So what will happen in the equations 1 and 2? The variable y is gone. So you will only have the variables x and z. So you will get two new equations, 5 and 6. When you substitute like that, you will get, so when you substitute 4 in 1, when you substitute 4 in equation 1, you will get a new equation 5. When you substitute 4 in 2, you will get another new equation 6. Now these equations 4 and 6 don't have the variable y, they'll only have x and z. Now solve these two equations and find the values of x and z, and hence find y. Is the idea understood, children?
Yes, ma'am. Ma'am, should I copy this too?
No, if you're interested, meaning you may.
Okay, ma'am.
We'll work it in a different way together, children. Write down this. We'll work it together in a different method also. Completed now. Very good. Done all of you?
1 minute. 1 minute, ma'am.
Yeah. Done, children? Yeah, I think that is sufficient time. Now see the other method. Now I'm writing. Is it over, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now see here, you can write the equations like this. This is equation 1. This is equation 1. And this is equation 2. Okay. Now you can write, I've written 1 and 2 below, one below the other. You can write 2 and 3, or you can write 1 and 3 now, anything. So supposing I write 2 and 3. 2 is this one. This is 2. And this is 3. Okay. So this is equation 1. This is equation 2. This is equation 2. And this is equation 3. Now what you decide which variable you want to eliminate. You decide which variable you want to eliminate. Suppose you eliminate y. Supposing you eliminate y. Okay. So see here. Plus y minus y gets cancelled. So you will get a new equation in x and z. What is that equation? 2x plus 2z is equal to 6. Or you can write this as x plus z is equal to 3. So you get a new equation 4. You get a new equation 4. Now here you eliminated y here, right? Eliminate the same variable y here. So for that you'll have to change the signs. Change the signs. Change the signs. All right, plus y minus y gets cancelled. So minus x plus 4z. Oh, okay, here. Plus 0 is fine, no? Plus minus, you don't have to change the sign here. So it's equal to 2. Change the signs throughout, children. Plus y minus y gets cancelled. X minus 2x is minus x. And plus 4z is equal to 2. Now this is equation 5. Now solve equations 4 and 5. Minus x, sorry, plus x. Solve equations 4 and 5, children. X plus z is equal to 3 is the fourth equation. Minus x plus 4z is equal to 2 is the fifth equation. Solve these two. So you get 5z is equal to 5. Z is equal to 1. Once you get the value of one variable, you can put z here, the value of z here. Z is 1 here. So you will get x is equal to 2. And then substitute in another equation which has x, y, and z and get the value of y. You can also do it like this. We have 3 equations, 1, 2, and 3. Solve, not solve, work equations 1 and 2, and 2 and 3, or 1 and 3. Since all the 3 equations have x, y, and z, you decide which one variable you want to eliminate. So supposing you eliminate y, you will get 2 new equations in x and z. Now solve those 2 equations and find the values of x and z and substitute in another equation to find the value of y. Is the idea understood, children?
Yes, ma'am.
So you can do it like this.
Ma'am, I found the answer using this method.
Oh, very good. I'm waiting so that you can also do it like this, children. Please work. All right, next one. Solve for x and y. You can see here. So you have only one equation, but look at this. 6x plus 5y is equal to 7x plus 3y plus 1 is equal to 2 into x plus 6y minus 1. You can take the idea from this and work. So equate these two to get one equation. You can equate these two to get another equation, or you can equate these two to get another equation. Here, equate these two, see here, and get one equation. Then you can equate these two and get another equation, or you can equate these two and get another equation. So take the idea from the slide and work, children. Equating like that, you get two equations and you can solve the equations to find the values of the variables x, y, and x and y. Finish, children?
Almost done.
Okay.
I have a doubt.
Yeah. Please ask me. Yes.
And from first equation, how we get x minus 2y is equal to -1.
Very good. Okay, fine. So we equate this one, right? 6x plus 5y is equal to 7x plus 3y plus 1. Is that understood?
Yes, ma'am.
Then we bring all the everything to one side. Okay, so you can see here this meaning I've taken these two to this side. Okay, so you can see 7x as it is. You can see this plus 3y as it is. Then the 6x I've transposed, so it's minus 6x. Then this plus 5y becomes minus 5y, and the plus 1 is there only. I've not transposed that. Basically, I've written these three terms as it is. 7x plus 3y plus 1 as it is. I've taken 6x and 5y to the other side. So 6x becomes minus 6x and 5y becomes minus 5 is equal to 0. 7x minus 6x is x. 3y minus 5y is minus 2y. And this plus 1, when you take it to the other side, it becomes minus 1. Should I tell you again?
No, ma'am, it's clear.
Okay. Similarly, with the other equation, see, you can transpose and all that the way you want. It's not that you also should do the same thing. You can transpose it however you want. Have x and y on one side and the number on the other side. That's all it is. Then I've equated this one and this one. So in the same way, multiply 2 with every term inside the bracket. Then take everything to one side. Take all the terms to one side and simplify the x terms and the y terms and get the second equation. Done, children?
Yes, ma'am.
Okay. Is the idea understood, children? We have 1 is equal to 2 is equal to 3. Equating 1 and 2, you will get a new equation. Equating 2 and 3, you will get a new equation. You can solve these two equations and find the values of x and y. Or you can equate 1 and 2 and 1 and 3. Okay. Any questions, children?
No doubt.
Okay. Look at this one again. Solve for x and y. So same thing here. Equate these two. Equate these two and get an equation. See how many variables are there? Only 2. X and y. Only 2 variables are there. Okay. So equate these two. You'll have to cross multiply, and simplify and get one equation x and y. Then you can equate these two and get another equation x and y, or you can equate these two, the first and the last one. I'll show you the answer slide. Take the help of the answer slide, go through the answer, and then I have worked it by the cross multiplication method, children, but you can do it by the substitution or the elimination method. Ignore the method I've used here. Ignore the method I've used here. This one is by cross multiplication method. Solving by the cross multiplication method. This you're not learning. So you just see how I have constructed the equations. You solve the two equations in your own way, elimination or substitution method, and find the values of x and y. Yeah, I'll just come back, children. Please complete this. 1 minute, just a minute. Children, I just want 10 minutes from you. Can I share these images on WhatsApp? Can you just work for 10 minutes? I'll just get back, children.
Yes.
See, the method I've used to solve is, oh, I don't think you have this. This is the cross multiplication method, children. You solve it in the substitution or the elimination method. Yeah. I've shared the images on WhatsApp. Yeah, please try these three. You can see the question as well as the answer. But in all the three, I have worked using the cross multiplication method. That's why I've crossed it there. So you please construct the equations and solve it by the elimination method or the substitution method. Yes, children, please engage yourself. I'll just come back in 10 minutes. Children, I'm back. What's the status?
Completed, ma'am.
All the three?
Yes, ma'am.
Yes, ma'am.
Very good. All right. So this was the first one, meaning I left you with three sums. Of the three sums, this is the first one. Okay, fine. So as I told you, equating these two. So when you equate these two, you'll have to cross multiply. So cross multiply, and then, like when you bring all the terms to one side and simplify, you get x minus y is equal to -4. So you can see here, when this goes here, it will become 3x minus 2x, which is x, and 3y minus 4y, which is minus y. And this minus 24, when it comes here, it will be plus 24. So minus 28 plus 24 is -4. So we cross multiply, and then we transpose, gather the xy terms on one side, number on the other side, and then this is the equation we get, x minus y is equal to -4. Then you can equate these two, or you can equate these two. So what have I done? I've done these two. Okay. So I've equated 2 and 3. Again, cross multiply. Again, xy on one side, numbers on the other side. This is the second equation. 2x plus 19y is equal to 118. Now, you'll have to solve these two equations. Maybe you can use the elimination method. So multiply this one by 2 throughout. So you will get 2x minus 2y is equal to -8. And the second equation is 2x plus 19y is equal to 118. So change the signs. This gets cancelled. Change the signs. So what do I get? Minus 21y is equal to minus 226. Minus 21y is equal to minus 226. So minus gets cancelled on both the sides. Oh, 126. So sorry. Thank you. Yeah, 126. 126. So y is equal to 126 divided by 21. So y is equal to 6. So like this, you can solve the two equations by the elimination method. Find the value of y, substitute, and get the value of x. Substitute here and get the value of x. Any questions here, children? I said this one is not for you. This is solving for x and y using the cross multiplication method. So here you have equations 1 and 2. So you have to you should have proceeded using the elimination or the substitution method. This is not relevant to you. This is solving by cross multiplication method. Okay. In this one, again, this one is the cross multiplication method procedure. So ignore this. Okay, so this is how we construct the two equations. Right.
Ma'am, in the equation.
Yeah. Let me explain this. Let me just explain it, and then I can attend to your question. Is that okay, Rakshita?
No, ma'am, you have missed a 4 there. That's what I wanted to tell. In the third equation.
Third equation, I've missed a 4, is it?
Yes, ma'am.
Oh,
It's
74. Oh, yeah. Thank you. Yeah. I missed to type 4 there. Okay. Thank you, Rakshita. Yes. So in the first equation, children, we have 7 to the power x plus 5 to the power y is equal to 74. So we're going to call 7 to the power x as a and 5 to the power y as b. So we have the equation a plus b is equal to 74. That's the first equation. A plus b is equal to 74. Now the next one is 7 to the power x plus 1. minus 5 to the power y plus 1 is equal to 218. Now, in exponents, when bases are same and it's multiplication, we add the powers. In exponents, when bases are same and it's multiplication, we add the powers. So now just think of the earlier step. Supposing this is the answer, then what should have been the earlier step? In the earlier step, you should have had 7 to the power x into 7 to the power 1. The earlier step I'm saying. If this is the answer, 7 to the power x plus 1 is the answer, what should have been the question? It should have been 7 to the power x into 7 to the power 1. So bases are same and it's multiplication, you add the powers. 7 to the power x plus 1. So in this equation, you're trying to write the earlier step. If the result is 7 to the power x plus 1, it should have earlier been this one, 7 to the power x into 7. 7 meaning 7 to the power 1. So bases are same and it's multiplication, so you add the power, 7 to the power x plus 1. Similarly here, 5 to the power y into 5 to the power 1. Bases are same and it's multiplication, so we add the power. We add the powers, 5 to the power y plus 1. So we're just writing the earlier steps. So this can be written like this, minus, this can be written like this, is equal to 218. So here, this one is A, 7 to the power x is A, 7 to the power x, this one is A, and 5, this one is B. So what is the equation second? The next equation, 7A minus 5B is equal to 218. So these are the two equations given to us. This one is A, this one is B. So the first equation is A plus B is equal to 74. In the next equation, we write this one as 7 to the power x into 7, which is 7 to the power 1. Bases are same, 7. It's multiplication. So we add the powers. So 7 to the power x plus 1. So in other words, 7 to the power x plus 1 can be written as 7 to the power x into 7 to the power 1. Supposing you had 7 to the power x plus y plus 1, supposing, then you can write it as 7 to the power x into 7 to the power y into 7 to the power 1. Supposing it was, 7 to the power x minus 3. Then it is 7 to the power x into 7 to the power minus 3. Supposing 7 to the power x minus 3, then it will be 7 to the power x into 7 to the power minus 3. So again, multiplication. So we add the powers x plus minus 3, which is x minus 3. Okay, so like that we get these equations in A and B. We get these equations in A and B. So on solving, how do you solve this? So you can multiply the first equation by 5. So you'll get 5A plus 5B is equal to 35. And next 7A minus 5B is equal to 218. Oh, not 35. This is 74, right? So 74 into 5. I'm sorry. 74 it is. So 74 into 5. 350, 370, correct? Okay. Now, 218, my God. Yeah. So now 5 plus 5b minus 5b gets cancelled. So you have 12a is equal to 885, 588. 12a is equal to 588. So a is equal to 588 divided by 12. I can see it here, it's 49. I can see it here, it's 49. So it is equal to 49. So now A is 49, A is 49, but our variables are X and Y, not A and B. A and B are the variables which we have introduced, but what are the variables given in the question? X and Y. So you should not find A and B and leave it there. You should solve for X and Y, that's the question. So what is A? 7 to the power X. A 7 to the power X, so is equal to 49 is 7 square. So when bases are same, you can equate the power. So x is equal to 2. X is equal to 2. This is again another property or another law of exponents. When bases are same, you can equate the powers. X is equal to 2. Now, when you substitute A is equal to 49 in one of these two equations, okay, when you substitute A is equal to 49 in one of these two equations, you can find B. And so B, I can see here, B is 25. When you substitute A, you'll get B as 25. B is equal to 25. But what is B? 5 to the power Y is equal to 5 square. B is nothing but 5 to the power Y. That's equal to 5 square. So bases are same. When you equate the powers, you get Y is equal to 2. How can I help you better, children? Please ask me if you have any questions. No questions, children?
No doubts.
Okay. All right. So here, see here, this is 2 to the power x plus 1. So it's 2 to the power x into 2 to the power 1. This one is 3 to the power y into 3 to the power 1 is equal to 59. So you can call this 2 to the power x as a. So 2a plus this one is b. So 2a plus 3b is equal to 59. 2a plus 3b is equal to 59. And here this is 2 to the power x into 2 to the power 2. This one is 3 to the power y into 3 to the power minus 1. So 2 square is 4. 4 into 2 to the power x. Here 3 to the power minus 1 means 1 by 3. 1 by 3. 3 to the power minus 1 is 1 by 3. Into 3 to the power y is equal to 61. So this one is b. And this is a. So the equation is 4a minus 1 by 3b is equal to 61. And then you take the LCM cross multiply. LCM cross multiply. This is the next equation. 12a minus b is equal to 183. So solve the two equations and get the values of a and b. So I can see here a is 16. So if a is 16, what is a? 2 to the power x. Because what is a? 2 to the power x. So if a is 16, that means 2 to the power x is 16. So 16 is 2 to the power 4. So x is equal to 4. You can see the steps here. B is 9. But what is b? 3 to the power y is 9. That means 3 power y is equal to 3 square. So y is equal to 2. 3 to the power minus 1 is 1 by 3 because in exponents, what we do is the reciprocal of the base. If you want to make this power minus 1 as plus 1. Okay, I'll tell you like this. Now see here, supposing you have 2 by 3 to the power minus 5. Okay, if you want to write the power as plus 5. If you want to write the power as plus 5, take the reciprocal of the base. Reciprocal of the base and write the negative of the power. These two are equal. These two are equal. Which two are equal? Supposing you have 2 by 3 the whole power minus 5. This can also be written as 3 by 2 the whole power 5. So to write the equivalent, in exponents to write the equivalent, what you have to do is take the reciprocal of the base and the negative of the power. Reciprocal of the base, negative of the power. 2 by 3 becomes 3 by 2. The base 2 by 3 becomes 3 by 2. And the negative of the power. So change the sign. Minus 5 will become plus 5. So in 3 to the power minus 1, okay, 3 means 3 by 1. 3 means 3 by 1. So it will become reciprocal 1 by 3. And minus 1 will become plus 1. Plus 1 means you don't have to write 1 is the power. No, so don't write it. 1 is the power. So don't write it also. 3 to the power minus 1. Reciprocal of the base. This can also be written as, reciprocal of the base. 3 by 1 becomes 1 by 3. Negative of the power, -1 becomes +1. That's why it's 1/3. That is why it is 1/3. Now tell me the equivalent of this one, children. What is the equivalent of -4/5, the whole power minus 2/3? Tell me the equivalent of this. What is the rule?
Minus 5/4 to the power to the minus 2/3.
Minus 5/4 to the power?
2/3.
Very good. Reciprocal of the base. Reciprocal of base. Negative of the power. Negative of the power. So minus 4/5. Its reciprocal is minus 5/4. Negative of the power. Minus 2/3 will become plus 2/3. Plus 2/3 will become minus 2/3. So this is the equivalent. The equivalent of this is this. Okay. Yes, children. So this is another type of question where you see that the coefficient excuse me. So what you observe here is that the coefficients of x and y are exchanged in the two equations. Okay, these are the two equations given to you. These are the two equations. What do you observe? The coefficient of x here is the coefficient of y in the next equation. And the coefficient of y in the first equation is the coefficient of x in the second equation. See, the signs can be different. It can be like plus here and minus here. It can be plus 330 here, minus 330 here. It can be minus 149 and plus 149. Ignore the signs. You can ignore the signs. Only the numerical value, that is the absolute value. The absolute value. That means not regarding the sign. The sign can be plus minus, it's okay. 149, 330. The coefficient of x in the first equation is the coefficient of y in the second equation. The coefficient of y in the first is the coefficient of x in the second. Signs can be different. If the equations are like this, then we use a special method to solve the equations. Only in this case, only when the equations look like this, when the coefficients are exchanged. Only in this case, you can use a special method. See, you can solve these two equations by the elimination method also, but it will take a long time. You can solve this by elimination method and still get the same answer. You can solve it by the substitution method and get the same answer. Just that since the numbers are large, you will take a longer time to do it. But the special method will help you find the values of x and y quickly, easily and quickly. That's the advantage. All right, children. Now see this method. How does the method work? The special method. So take up the two equations. Take up the two equations. Add the two equations. Write them one below the other. See it? Equation 1 plus equation 2 gives. Write the two equations one below the other. Don't change the signs anywhere. That is adding. Meaning do not change the signs in the second equation. If you do that, you're adding the two equations. If you change the signs in the second equation, see it? Minus becomes plus, plus becomes minus, minus becomes plus. If you change the signs in the second equation, you're subtracting the two equations. Okay, so I write the equations one below the other, these two equations one below the other, and we're going to add the two equations. That means we don't change the signs in the second equation. Okay, now what do you get on adding? 149x minus 130x is minus 181x. Then minus 330y plus 149y is minus 181y. minus 511 minus 32 is minus 543. Now you will see that 181 is a factor of 543. Take out 1 minus 181. You can even take 181 common, anything, 181 or minus 181 common. Okay, so then you get x plus y is equal to minus 543. So x plus y is equal to minus 543 by minus 181. Minus cancels and you get x plus y is equal to 3. So see, a very simple equation we got, x plus y is equal to 3. Now again write the two given equations, the original equations 1 and 2, and subtract the two equations. That means change the signs, minus plus, plus minus, minus plus. Change the signs throughout the second equation. Change the signs throughout the second equation. That means you're subtracting the two equations, equation 1 minus equation 2. And that when you do, you get this one, whatever you see here, and 479 is common. And then that comes for division to the other side, x minus y is equal to minus 1. So like this, by adding and subtracting the two equations, you get two simpler equations, 3 and 4. Now solve these two equations, 3 and 4, to find the values of x and y. This is easy, children, to understand?
Yes, ma'am.
Yeah, children. Please write down. Any questions, please feel free to ask. You can do anything first. You can first subtract the equations and then add the equations. Any order is fine. Write down and let me know when you finish.
Ma'am,
Yeah.
ma'am, I'm getting the same value, ma'am, but for different variables.
Oh, that is you're getting x as 2 and y as 1, is it?
Yes, ma'am.
Do you get these two equations?
Ma'am, I got minus x minus y is equal to minus 3 and x
Correct,
minus
correct.
y is
Minus
equal to
x
3.
minus y is equal to minus 3 and
X minus y is equal to 1.
no, that's wrong. X minus y cannot be 1. Did you get this one?
Yes, ma'am, I did a mistake in the sign, ma'am.
Yeah, you would have written plus 479.
Yes, ma'am.
Yeah, it's minus 511 plus 32. So it's minus 479. Done, children?
Yes,
ma'am.
All of you?
Yes, ma'am.
Okay, so this method is called the special method. And when is this used? Only when the coefficients are exchanged. 149 is the coefficient of x here. And in the next equation, 149 is the coefficient of y. So in the first equation, 330 for y. In the second equation, 330 for x. I said ignore the signs. It can be plus minus, difference can be there. But the number, the absolute value should be the same. In this case, we use a special method. We add the two equations, get a new equation 3. We subtract the two equations, get a new equation 4. And we solve equations 3 and 4 to find the values of x and y. Got it. Yes, children. Let's take a quick class test. Oh, is it the same thing which which we just did? Yeah, I think yes. Okay, we'll skip this and go to the next one. Yeah. Take down this question. Yes, children. I'm curious to know what you've got.
Still working, ma'am.
Okay. All the three equations have the variables x, y, and z. So, can you share your idea? How are you working it, Madhumita?
Ma'am, first I've taken the equations 1 and 2, and then I equated them, and I got 97x plus 205y is equal to minus 11 by eliminating z. And then
You said by equating. By you took equations 1 and 2 and you tried to use the elimination method there.
yes,
You eliminated z. Okay. So you have got a new equation in x and y, correct?
yes, and
Okay,
then
then
I'm doing the same for equation 2 and 3, ma'am.
okay. So for in equation 2 and 3, again you're using the elimination method and you're going to eliminate which variable?
Z, ma'am.
Here also z. So you'll get another equation in x and y. Very good. Yes. Class, use the emoji. Raise your hand. Ritika, Prajit, Madhumita, Krishmi, Danya, Raghavi, Rakshita, Raja, Sashank, Florentina, Shri Ranjan, and Diliban. Okay. But Diliban, are you there?
Yes, ma'am.
Okay, okay. Very good, children. Fine, continue. Prajit, how are you working it? Share your idea.
I wrote z in terms of x and y for the first equation, and I'm substituting it in the other equations.
Very good, very good. Nice idea. Yes. It's crazy, the equations. That's why we have the cross multiplication method. In such cases, the cross multiplication method will help us get the answer quickly. Now, since it's only the elimination and the substitution method, it'll take a little longer time to get the answer. This is when we use the cross multiplication method. When the coefficients are really large, then the cross multiplication method is very easy. It takes less time to get the answer. So I have taken 1 and 2, 1 and 3. I've taken equations 1 and 2, 1 and 3. And I try to eliminate Z in both the cases. 1 and 2, 1 and 3. Eliminating Z. Yeah, so we have two different equations in X and Y now. We'll have to solve these two and find the values of X and Y. Okay, children, since shall I wait for you? Are you close to the answer or you need help? Response.
Ma'am, I took up equation 2 and 3 and I got confused and I got a wrong answer, ma'am. So I couldn't simplify it any further, but now using your method I'm doing it now.
Yeah, the numbers are crazy. I told you, numbers are crazy, but yes, but since you don't have the cross multiplication method, you have to do the elimination of the substitution method.
I'm getting it as minus 97x minus 205 y minus 11 is equal to 0.
Your substitution method, is it?
Yes, ma'am.
Yeah, that I have here. You can see. Here I have worked the way you told me. And you can see the numbers are large, so use the cross multiplication method. See, this is the cross multiplication method. So this method you cannot use. We use this method when the numbers are large. So I think I've done it the way you did it, no? See here, from
Yes.
equation 1, I wrote Z as something. And then I've substituted that in 2 and 3. Yeah, exactly what he told me I've done here. I've taken equation 1, I've written Z in terms of X and Y, and I substituted that in 2 and 3. And are these the equations you've got?
Yes, ma'am, I got those equations, ma'am.
Very good. Yeah, now you have to solve these two equations and get the values of X, Y, and Z. All right, children, I think I'll just leave this as homework. You know the method. Okay, so you please complete this. You can see the answer. You can see the answer here. You can take a screenshot of this one also. Yeah, the values of X, Y, and Z. 2, -1 and -1. 2 -1 -1. So x plus y plus z is 0. We have to find the value of x plus y plus z. So after finding x, y, and z, you should find the value of x plus y plus z. It's 0. This is taking equation 1, writing z, see equation 1 and writing z in terms of x and y. Now leave equation 1. Substitute this z in 2 and 3. And that way you get two new equations, solve and find the values of x, y, and z. Take a picture, children. Take a picture of this one also. So here, this is a different method. This is a different method. Equation 1, equation 2, equation 3. I've taken equation 1 and 3. 1 and 3, eliminated z. Then I've taken 1 and, 1 and 2 and 1 and 3. 1 and 2, 1 and 3. Just a minute. Yeah. Can we move on, children?
Yes, ma'am.
Sure.
Okay. Yeah.
1 second, ma'am. I'm going to find.
Yeah. A man, when asked how many hens and buffaloes he has told, he has. Oh, okay, okay. I don't know. I've made some. I'll just see here. Animal, he has, okay, a man has some number of hens and buffaloes, okay. So he says his animals have 120 eyes and 180 legs. See here, there's something wrong. I've gone wrong in typing, but this is the message through the question. So a man, he says he has some hens and buffaloes. The animals together, they have 120 eyes and 180 legs. Okay, in the animals, they have 120 eyes and 180 legs. Taking the number of hens as x and buffaloes as y, frame linear equations for the given information. The animals, both hens and buffaloes together. The animals, both hens and buffaloes together have 120 eyes and 180 legs. Frame the equations, children. Yeah, write down the question.
Ma'am, the question is right, but just that after has there should be a comma, ma'am.
Ah, that's what. It looks very not able to read it correctly. A man, when asked how many hens and buffaloes he has, he has told that his animals have. Yeah, correct. With a comma, it makes sense. So when this man was asked how many hens and buffaloes he has, he's told that his animals have 120 eyes and 180 legs. Yeah. Take the question and frame the equations.
Ma'am, is it 4x plus 6y?
Yeah, tell me 4x
4x plus 6y
is equal to
is equal to sorry, I did not complete that. 300.
no. Try think no.
Ma'am, I got the first equation as x plus y is equal to 60.
No, tell me before you reduce the equations. The first one.
2x plus 2y is equal to 120.
Who was this?
Ritika, ma'am.
Ritika. Okay, then the next equation.
Next equation is 4x plus 2y is equal to 180.
4x, huh?
Yes, ma'am.
4x.
Ma'am, for buffaloes, it's 4 legs, no, ma'am. And for hens, it's 2. Hen, it's 2.
But you said 4x.
Okay, 4y plus 2x.
So, tell me
Is
x
equal to
first.
180.
Tell me x first.
2x.
2x.
2x plus 4y is equal to 180.
Very good. Very good.
Yes.
Ritika. Very good. So, children, the animals have 120 eyes. Hens have 2 eyes. Buffaloes also have 2 eyes. The total number of eyes is 120. The total number of eyes is 120. Okay. So how many hens are there? X hens. So how many eyes? 2x eyes. If there are 60 hens, 120 eyes. If there are 4 hens, 8 eyes. 5 hens, 10 eyes. Buffaloes. Supposing 12 buffaloes, then 24 eyes. So the first equation will be number of hens is x. So eyes will be 2x. Number of buffaloes, y. So the number of eyes will be 2y. The sum is 120. The total number of eyes is 120. How many hens are there? X hens are there. How many eyes will X hens have? 2x eyes. How many buffaloes are there? Y buffaloes. Then how many eyes will these buffaloes have? 2y eyes. Now the number of eyes among the hens and buffaloes together is 120. So you add an equator to 120. Now coming to legs. How many hens? X hens. A hen has 2 legs. A hen has two legs. So 2x legs. X hens. How many legs? 2x. How many buffaloes? Y. How many legs? 4y. The total number of legs is 180. You can reduce the equation. So this will become x plus y is equal to 60. And this will become x plus 2y is equal to 90. These are the two equations.
Ma'am, there are 30 hens and 30 buffaloes.
30 hens and 30 buffaloes. Okay. 30 hens and 30 buffaloes. Huh? Okay. Yeah. 30, 60. All right. So this is the next question, children. One second, 1 second. Yeah. Frame the equations. Yeah. You can write the question later. Tell me the equations, children. Dilipan, try the equations.
Ma'am, can I?
Yeah. Okay.
Ma'am, x plus 20y equals to 37.70. And x plus 20y equals 37.70, and x plus 26y equals 48.50.
Okay. Let's see what the others have to say, and then we'll understand.
Ma'am, can I
the
try?
right. Yeah.
20x minus y is equal to 37.70.
20x minus y. Okay.
And 26x minus y is equal to 48.50 now.
What is it? 20x minus y? I don't understand. What's that? What is 20x?
The total distance now.
Okay, but why minus y?
Ma'am, 1 kilometer's charge.
Okay,
Ma'am,
fine.
can I?
Who's that? Rakshita?
Yes,
Yeah.
ma'am.
Hmm.
Ma'am, x plus 19y equal to 37.770 and x plus 25y equal to 48.50.
Perfect. Very good, Rakshita. Very good.
Thank you, ma'am.
Yeah. So, children, what is the question? The question is, if you travel by an auto rickshaw, the fare is like this. For the first kilometer, you have to pay X rupees. The auto fare for the first kilometer is fixed. The auto fare for the first kilometer is different from the rate per kilometer for the remaining distance. So for the first kilometer, the rate is different. That is fixed. And the rate per kilometer for the remaining distance is different. See that word remaining distance. Remaining distance. First kilometer says 10 rupees. Let's take an example. Now, supposing the automan says for the first kilometer, you have to pay me 25 rupees. Okay, and supposing you go a total distance, supposing you go 10 kilometers. He says for the remaining distance, he says rupees 10 per kilometer. For the first kilometer, you have to pay him 25 rupees. Then for the remaining distance, you'll have to pay him rupees 10 per kilometer. So what is the total distance you have gone? 10 kilometers have gone. So split that as 1 kilometer That is fare for 1 kilometer. Fare for 1 kilometer plus fare for 9 kilometers. Okay. What is the fare for the first kilometer? 25 rupees. What is the fare for the remaining 9 kilometers? 9 into 10, 90 rupees. So totally you will pay him 90 plus 25, which is 115 rupees. The fare for the first kilometer in our example is 25 rupees. The fare for the remaining distance in our example is rupees 10 per kilometer. Now, supposing you use the auto to travel a total distance, you hire an auto and you travel a total distance of 10 kilometers. So when you get off the auto and pay the automan, you will split your distance 10 kilometers. Your total journey of 10 kilometers as 1 kilometer and 9 kilometer. So for the first kilometer, your the fare will be 25 rupees. Plus, now the remaining distance is 9 kilometers. For the remaining 9 kilometers, you will pay him at the rate of 10 rupees per kilometer. So 90 rupees. 90 plus 25, which is 115. In the same way here, in the first case, the total distance, in the first case, the total distance is 20 kilometers. So you split it as what? 1 kilometer and fare for the first kilometer. Fare for first kilometer plus fare for 19 kilometers. What is the fare for the first kilometer? That is fixed X. Plus, what is the fare for the remaining 19 kilometers? 19Y. And this total is 37.7. The fare for the first kilometer plus the fare for the remaining 19 kilometers is equal to the total fare of 37.7. Fare for the first kilometer is different from the rate per kilometer for the remaining distance. Why will you pay for the first kilometer and 20 kilometers again? So that's what Raja said. Raja is very liberal in paying. He's very liberal. He's going to pay X rupees for the first kilometer and he'll also pay 20 for the for the full 20 kilometers. See, good people like you should exist in the world. But mathematically, you're wrong. Because for the first kilometer, if you've already paid him X rupees for the first kilometer, then why should you pay him again for the whole of 20 kilometers? You should pay him only for 19 kilometers. You have paid him X rupees separately for the first kilometer. Then for the remaining distance, 19 kilometers, Y rupees. This total is 37.7. And next 26 kilometers. So for the first 1 kilometer, it is X. Plus for the remaining 25 kilometers, the total is 48.5. Yeah, right on, children? We'll complete this and wind up the session for today. Don't leave the meeting. Please finish this and...
Ma'am, I got the correct answer for Y, ma'am, but not for X.
Why not for X?
I got 1.7 for X, ma'am.
Read what you've worked.
100x plus 2000 into 1.8 is equal to
Read
3000.
after this. Read after y is equal to 1. You got y is 1.8, right?
Yes, ma'am.
Yeah, after that you read. After that.
Yes, ma'am. After that only, ma'am. 100x plus 2000 into 1.8 is equal to 3.37.
Why are you substituted in these equations? No, why are you substituting here? Substitute in these equations. Okay, no problem.
No,
fine. Okay, you tell me.
I took the decimal out, ma'am. That is why.
Okay. Okay, 100x.
100x plus 2000 into 1.8 is equal to 3,770.
That's what you have taken 20y, is it?
Yes, ma'am.
It's 19y.
But it is 20 kilometers, ma'am.
No, you were not listening. I did explain that. See, Sashank, it's very clearly given in the question that for the first kilometer, the rate is different from the rate per kilometer for the remaining distance. You tell me, now supposing you hire the auto. Sashank, are you listening to me?
Yes, ma'am.
Yeah, now suppose, so you have hired the auto and you cover a total distance of 20 kilometers, okay? Now the automan, he is charging you separately for the first kilometer. For the first kilometer, he is charging you X rupees. Then you will pay him only for the remaining 19 kilometers, right? Why will you again calculate for 20 kilometers? For the first kilometer, you're already giving him X rupees. Now for the remaining distance, 20 minus 1, 19, you will be paying him Y rupees per kilometer. So okay, which makes X plus 19Y is equal to the total fare of 37.7. Yes or no? Now tell me for the next one. 22nd case is 26 kilometers. So for the first kilometer, you're going to pay him X rupees. For the remaining 25 kilometers, because you've already paid him separately for the first kilometer, X rupees. So now 26 minus 1, for the remaining 25 kilometers, you will be paying him at the rate of Y rupees per kilometer. So it will be 25Y. So 25Y for 25 kilometers plus X rupees for the first kilometer. The total is 48.5. Am I clear, Sashank?
Yes, ma'am.
You ask yourself, why will you pay him for the first kilometer separately and again for the 20 kilometers? If you have paid him for the first kilometer separately, then for the remaining 19 kilometers only you will calculate, no?
Yes, ma'am.
Yeah. Okay, it's going to be 9:40, children. Okay, if you have not finished, take a screenshot. If you've not finished, take a screenshot. As Sashank was telling us, you can also multiply this equation by 10 to get rid of the decimal point. So you can make this equation 10x plus 190y is equal to 377. You can also multiply this by 10 and make it 10x plus 250y is equal to 485. You can even work without the decimal point. I have worked with the decimal point. You can also get rid of the decimal point by multiplying this equation by 10 and this equation also by 10. You can get rid of the decimal point. Okay, take a picture, children, and complete this.
Yes, ma'am.
Okay. All right, children. So that's it for today's session. Thank you so much. You may leave the call. Good night.
Thank you.
Thank you, children.
Thank you, ma'am.
Thank you, ma'am.
Thank you.
Thank you, children. Good night.